Assalamu alaikum students, this is Farwa Batool, your O-level computer science instructor, and welcome to another video. In the previous video, we have started the topic of test data. I have explained each and everything about test data along with its types. Now in this video, we are going to solve the example of book. There are two examples in your book for test data. Let's quickly see that. Number one is already been explained in the book, but I'm going to explain you this again. For example, consider an algorithm that records the percentage marks. It is mentioned that the algorithm is recording percentage marks. It means that the marks must have a range of 0 till 100. Entered in whole numbers. Whole numbers means that the marks will not be any decimal value or any string value. It will be an integer value. So here you can say that the algorithm is going to check for the range. It's a range check validation over it on the data. And the second thing is your type check validation, because it says that it must be a whole number, or in other words, it must be an integer value. So it's a type check. Okay. Now, from 10 and 2 term examinations, the total entries it is going to accept, the algorithm is going to take are 10. There are 10 examinations and 10 different marks, percentage marks will be entered in your algorithm for a student, and then finds the average mark. Then the algorithm is going to calculate for the average percentage of it. Now, a set of normal data, test data for this purpose could be, it is already given over here that let's suppose if I consider normal test data, then the 10 entries can be, let's suppose a student has taken 50% in each of its exams. So it's written 50, 50, 50, 50, 10 times. Why 10 entries? Because these are 10 exams. So in every exam, the student has scored 50% marks. Now the average, the expected result is going to be 50. Why? Because when you are going to calculate the average of it, and you will divide it by number of examinations that are 10, you will get 50 result. So the average as per the normal test data, the expected result is 50. Now, when you are going to test your algorithm with this normal test data and you get the value 50% as an average, it means that the algorithm is working correctly. There is no error in it. But let's suppose if there is an error in algorithm, let's suppose it gives you the result 70 or 25. So there must be some error in the algorithm that you need to correct. This is how the test data helps you to find out if the algorithm is working the way it should or not. Now let's see another example for the normal test data for this example, for the particular algorithm. Let's take a more realistic example. Let's suppose there is a student who has taken different percentages in different exams, like 25%, then 56%, then 74%, then 89%, then 21%, then 34%, then 20 or 57%, 1, 2, 3, 4, 5, 6, 7. Let's add 3 more, 68, 89, and let's suppose the last one is 90. So this is a more realistic data that the student has attained different percentages in different exams. Now, what would be the expected result? Let's calculate the average of all of these percentage marks and write down the expected result for our algorithm so we can check once we put all this normal test data in the algorithm. We should have the expected result of our normal test data. Let's calculate it manually. Okay, so the calculated result of average marks is 60.3. And if the algorithm gives you a whole number of average, then it will be 60%, the expected result. So if you said that it must be an integer value for the average percentage, then it will be 60. That will be displayed on your screen after as a result of algorithm. Now, let's suppose this data is used as normal test data in your algorithm and you are not getting the average percentage as 60%. Instead of that, if you are getting some other value, let's suppose 35 or 83%, so definitely, since your actual result is not verified or it's not similar to your expected result, so you can say that there is some error in your algorithm. Now, this is an example of normal test data that is the expected data and that is always accepted by the system. Now quickly see the other examples of test data. Okay, after the normal test data, let's talk about extreme test data. What can be the example of extreme test data in this case? Okay, remember that extreme test data is the one in which you are going to take the upper value, upper limit and the lower limit of your percentage mark. So the percentage mark range is from 0 to 100. So the lower limit is going to be 0. You cannot enter any value that will be less than 0 or any negative number. And you cannot enter any percentage mark that is greater than 100. So the upper limit of your test data would be 100. If the user enters 102, 103, so it will be considered as abnormal data. So here we go, extreme test data 0 and 100. Now quickly moving towards the third type of data for this example, that is the boundary test data. In the boundary test data, remember that you will be having two pairs at each end of your range. So this is the lower limit, and this is going to be the upper limit. And remember that the pair must be in such a way that one value will be rejected and the other will be accepted by the system or algorithm. If you are not getting it, you can go ahead and see my previous video in which I have explained all of these types in detail. Okay, now the lower limit that will be accepted is 0 and the immediate value that will not be accepted is -1. I cannot take 1 because 1 is also immediate value, but it will be accepted by the system since it is within the range of 0 till 100. So we cannot have a pair in which two values will be accepted. We need to take such a value, the immediate value of lower limit that will be rejected by the system. That will be -1. Now for the upper limit, I know 100 is the upper limit that will be accepted by the system. Now just after 100, the immediate value that will be rejected is 101. I'm not going to take 99. Why? Because 99 is such a value that will be accepted by your system. This is within the range and this is also a whole number. So remember that. You need to take the immediate value with the upper and the lower limit that will be rejected by the system. These are your boundary test data, the two pairs, -10 and 100, 101. Now quickly moving towards the fourth type of test data that is known as abnormal test data. There can be different type of abnormal test data for this example. Abnormal test data. Okay, the first thing is if your data is violating the type check, that is, if the value is not a whole number. Let's suppose you enter something in a string. If the number is entered in a string, just like instead of writing 11 in a numeric form or integer form, you write it in form of characters. So definitely it's a violation of type check. So this value, the expected result will be, remember that for abnormal data, the expected result is always rejection by the system. You can say the value will be rejected, will be, sorry for this disturbance, okay, will be rejected by the system. This will be your expected result. 11 in form of a string will never be accepted by your algorithm. Other than that, no negative numbers will be accepted like -3, -99. Why? Because this is going to violate the range check. Remember that the range is from 0 till 100 for all the percentage marks. So you cannot enter any negative number and you cannot enter any value greater than 100, like 200 or 301 and so on. And the third thing is also the decimal values, any floating number, any float that is 22.7 or 32.6, no decimal value will be accepted by the algorithm because it is already mentioned that all the values must be a whole number and must be within the range of 0 till 100. So all those numbers that are going to violate these two validation checks, they will be considered your abnormal test data for this particular example. Now we have already, okay, we are done with this example. Now I am quickly moving towards the next example or the activity that is mentioned in your book here. Why I am doing this? In order to make you clear about the test data, how we need to find out for different examples. Okay, the first question here for activity 7.11 is provide boundary data for the upper end of the range. Assume that the percentage marks are always whole numbers. So it's very easy. We have already done the upper limit was 100. They are talking about the same example that we are done with. So the boundary data for the upper end was, we know that the extreme data was 100 for the upper limit. All the percentage marks can go maximum till 100, not more than that. And one value must be rejected. That is going to be 101 because you have to take it as a whole number. You cannot take 100.6 or 100.1. No. Okay, so if you will take the whole number just after 100, that will be rejected by the system. It will be 101. This is your question number 1. Now quickly moving towards question number 2. I'm doing it here. The end of term examinations are now marked out of 20. It means that now the range will be from 0 till 20. And remember that the numbers will be entered in whole numbers. Whole number means that the normal data for this will be, okay, sorry for this. Let's do it one by one. Let's start with this one. Two sets of normal data and their expected results. Okay, so in part A of question number 2, let's do for normal test data. You have to do it the same way that you have done the previous example. Just mention 10 numbers that must be out of 10, 20 that are marked out of 20. So it can be for one student, let's suppose 7, 15, The values must be within the range. Remember that. Okay. Okay. 15, let's suppose 20, then 9, then 13, 16, 5, or 10, and another value 6 or 19. These are the 10 values that the student has occupied in 10 examinations. Now quickly find out the expected result for it. Let's find out the average of all of these numbers. Okay, so I have calculated the average of all of these numbers, that is going to be 12. So when you are going to put the test data, normal test data, this one in your algorithm, you will get an average value of 12. So this is one type of normal test data that you can put in your algorithm. And let's take other example, because it's written here, two sets of normal data and their expected results. So the other normal test data can be just like that. Remember, the normal test data is the one that will always be accepted by the system and will have an expected result. So again, let's suppose for another student, the marks attained are 8, 13, 9, 5, 14, 10, oops, then 15, 19, 7, or 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 entries for a student marks. Now, the expected result, again, you can calculate manually and write down here. The expected average for all of these marks can be. So now for this example, the average marks will be 10. So if you put this normal data in your algorithm and you get the answer, the actual result matches your expected result. So you can conclude that yes, the algorithm is working the way it should. Now quickly moving towards the part B of this question. Part B says that some erroneous or abnormal data and their expected result. Very easy. Let me write down abnormal data for this example. Just like the previous example, the abnormal data will be violating the range check. It means any value that is negative, less than less than 0, and any value that is greater than 20 now, because the range is from 0 till 20. So 21, 25, 100, and so on. These will be your abnormal data. Other than that, any string, let's suppose you write down 23, or even if you write 20, 20 is your range, but since it is written as a string, so it will not be accepted. And any decimal value, 12.7, will never be accepted by the system. So for all of these values, the expected result is going to be, you can simply write, the expected result is, the value will be rejected by the system. Will be rejected by the system. This is going to be your expected result. None of these values will be accepted by your algorithm. Now quickly moving towards the third one, two sets of boundary data and their expected results. Now, for the boundary data, quickly see that you must have the upper values and the lower values. Here and here. The lower value that will be accepted is 0, and the immediate value that will be rejected is -1. Similarly, the upper value accepted is 20, and the immediate value that will be rejected is 21. So you can just write down the expected result like this. This value will be, write down, rejected by the system. This will be accepted by the system. For the value 20, it will be accepted by your algorithm. And 21 will be rejected by your algorithm. So this is going to be the expected result for your boundary test data. Okay, so this video got too much lengthy. Sorry for this, but I really wanted to explain you each and everything in detail. Thank you so much for watching this video. Stay tuned, stay connected, and do not forget to subscribe the channel. Bye bye.